subject for today is track and turnouts. So first, just going to go over the different kinds of tracks. So this is the kind of stuff that comes in sets. Well, it comes in sets today. Does this look familiar? Cool. So this is a sectional track that is pre-bedded. Some people call it pre-bedded track. Some people call it ready track. Regardless, so it already has that road bed built into it. This is from Bachmann. Cato also makes some that are really nice. I have a loop of their stuff at home. And then Atlas also makes some as well. So this is what comes in the sets. Of course, y'all also may remember sectional track that look more like this. So this is sectional track that does not have the road bed built into it. It's just the track itself. If you lay this down directly on top of plywood, it's going to be really noisy and it's going to be just flat on the ground. Adding the road bed in there, which is typically cork, which I'll talk about shortly, that builds it up, makes it look more realistic, gives you a little bit more depth to work with in terms of terrain, and gives you better operation as well. So right now we've got, I'll just go back to these two, we've got two flavors of track going on here. This is from Bachmann. About half their sets come with the gray bedded track, about half their sets come with the black bedded track. So the gray bedded track has a nickel silver rail, the black bedded track has a mild steel alloy rail. So the biggest difference between these two, you'll notice, this will tarnish, this will rust. I grew up in Houston, Texas, which is a glorified paved over swamp that I love dearly, but it's still a swamp. So these would rust very quickly. Not as big of a problem in this climate here, but it's still a thing that happens. Bachmann, they're the only ones that I'm aware of that are still producing track with a mild steel rail. You also may remember the old brass rail that used to be on stuff. That's pretty much all gone out of vogue. The brass rail, it does have, has all right electrical pickup, but it's a pain to keep clean. So for, just the mildly extra cost of the nickel silver, you get something that has much better electrical pickup. It's easier to keep clean and will provide you with much better operational capabilities. So, like I said, this is what comes in the sets. In terms of what Bachmann makes, they make a lot more for this stuff than they do for this stuff. But this stuff, supposing you get a set, or your kid or your grandkid gets a set, and it comes with this, you don't have to throw all this away to begin with. You can start adding on to it with this. So this stuff here, totally interchangeable. I say as, doesn't want to go together, yep. It's the same, I use the same molds for the track and stuff, it's just, this one, they use nickel silver rail and a gray plastic. This one, they use mild steel rail and a black plastic. So I'll pass these around here. Something to note as well, these tracks are also called code 100. So the code of the rail is the height of the rail in thousandths of an inch. So that's something kind of important. You'll see stuff that set packages say like code 100, code 83, code 70. So like this turnout here, this is code 83. This turnout here, this is code 70. So that just means that purely from the code perspective, that they have, one has a larger rail, one has a smaller rail. That's because if you've ever been out, around train tracks, you may notice it more in like a yard or going off of a spur, that different tracks will have different sizes of rail. Obviously, because bigger the rail, the more steel, the more expensive it is. So you're only going to want to use that where you really need that extra durability that comes from a larger rail. Code 100 rail translates to, in real life, about 150 pound rail. So rail is measured by pounds per yard. So if it's 150 pound rail, that means you cut a 3-foot section of it, it's going to weigh as much as, your average high school male. So there's that. In terms of like what that translates to in real life, if you think about it this way, a code 100 rail in real life is going to be coming up to about here on you, about halfway up your shin, which if you think about it, how often do you really see that out there? If you've got your foot right next to the rail, how often does it come up that high? So that's why most people, or I shouldn't say most, a lot of people will use a smaller size of rail, like code 83 or code 70. The vast majority of stuff that's available is in code 70, code 83. So code 83 and code 100 are going to be your most common. Code 70, Shinohara made a lot of stuff for that. However, Shinohara went out of business earlier this year. Company, they've been around a million years making track and turnouts. Walthers, they produce the code 83 turnouts for Walthers. Walthers bought they bought the molds and such for those, the tooling to actually make those, and they're reproducing those right now. However, they didn't do that for the Code 70, but Micro Engineering is making more Code 70 track. In addition, Pico, which is an English company, has also announced that they are making an American profile Code 70 track. You can see the difference in the rail size here between these two pieces here. So this Atlas is pretty simple. All their Code 100 stuff has black ties. All their Code 83 stuff has brown ties. So I'll put these two pieces together here, and you can see that there is a pretty noticeable height difference. And here, pass this around. They're both nickel silver rail. They're both the same gauge, but the height of the rail is different. That doesn't mean you can't use them together. That just means you have to do a little bit of forethought to do that. To do that, you have to use joiners like these here. These are from Micro Engineering. These are called transition joiners or compensating joiners. So this is for Code 83 to Code 70 track. So what this does is, say you've got, this is your 100 here, Code 83 here. So what that joiner does is it grabs around the bottom of the rail, lifts up the shorter side such that the top of the rail matches, which that's the important thing, is making sure that the top of the rail matches. You don't really care where the bottom of the rail is. All you care about is where your train's crossing. Track, it's good if you're starting out, but you're limited. You're limited to whatever the geometry of those tracks can give you, which leads into the next thing, flex track. So anybody ever used this before? Cool. So it is, as the name implies, it is a track that is flexible. Once again, engineers have proven themselves to be very creative at naming things. So this here is Code 100 Flex Track. This is from Micro Engineering. There are several different manufacturers that make track. There's Pico, Atlas, Bachmann, Micro Engineering, Shinohara. Even though they're out of business, we still have a lot of their track, and a lot of it's still out there. And it all does the same thing. It'll all bend. You'll be able to do the same things with it. The only difference is to what degree you'll be able to do things with them. So the ease, so the Micro Engineering stuff, it's a little bit harder to bend. So here you can see it's not too hard to bend, but say if you like to paint your track, and I'll talk about that in a little bit, it does get a little bit harder to do. So, and you'll notice as well when I pass this around that the detail level on this is really fine. So, you know, if you've got, say, your rail here.
We are dog friendly.
Let's assume that is a perfect rail. You've got your tie plate here on top of the tie. And you've got spikes holding down the rope. Once again, there's a reason I didn't go to art school. So, on the Micro Engineering stuff, the detail level on this is very fine, and it's a very scale size. Comparing that to, here I'll pass this around.
What gauge is that?
That's HO. So everything I'm going to be talking about today is
scale?
HO. HO standard gauge.
Either Code 83 or? Yeah.
Oh, sorry, that's Code 100.
Okay.
So all the pieces of track I'm going to pass around right now, they're all Code 100. But they're all from different manufacturers and are all just a little bit different. So you can see which is which. You know, see that even though they're the same, they're also very different. So this is from Pico here, and this stuff is very easy to bend, but the ties, since they're an English company, they do things, their tie spacing is just a little bit different. So if you compare to the Atlas here, so Atlas, American company, also super easy to bend, concrete ties, they're pretty similar. They, you know, in terms of the actual individual tie, the detail level I would say is, in my opinion, a little bit finer on the Pico, but the tie spacing, ties are spaced slightly further apart. So if you're somebody who cares about how your track looks, that may be something that you notice and go, oh no, I don't like that. Even though it's good track, that tie spacing, that's just a deal breaker for me. It all depends, you know, on what you're doing and how you want your track to look. So pass these around again. The first piece that's coming around with the wider tie spacing, that's from Pico, the English company, and this is from Atlas. The piece that's coming around now, this is also a Micro Engineering Code 100 piece. It's made in the same mold that that first piece was, but it has weathered rail. So they've treated the rail with a chemical solution because, you know, if you see it in real life, rails are never silvery shiny. They are dirty, grimy, rusty, and in general look like doo-doo. So this is a way to make your stuff look like doo-doo. The rail's just chemically treated with actually this solution here, which is something that you can buy and add on after the fact. That'll turn the rails this wonderful shade of brown. You just take a paintbrush, apply this along the rail, and this will change the color of the rail.
Okay. Right.
How does that affect the electrical?
It does not. Well, or a couple other options you can do. You can paint the track. So personally, this is what I use to paint my track, and I will typically, before I get ready to lay my track, I've got a couple sawhorses that I set up in my garage, and I'll give the track a few good coatings of this. Then I'll go to my layout, bend the track to how I want it to be. But by painting it, it does make it harder to bend. But once I get it bent to the shape I want, ties will have moved, some of the paint will get chipped off. So I'll give it one quick coating with this, let it dry overnight, and then come back the next day and lay my track. But you may say, oh no, then you've got a layer of paint on top of the track there. I come back with a sanding block and just polish off the top of the rails. That'll take off that top layer of paint and give you a nice look. Here I'll hold this one here. So this is a little demonstrator that I built. This is all the main here. This is all micro engineering code 83 track. You'll notice from here on, this is not painted and this is painted. So if you can see that there, that's just it. What I like about it is it takes off the plastic sheen from the ties, just a nice dark brown color. Makes it just look more realistic, particularly once you ballast it. So you can see the before and the after there. So curves. So has everybody, like space-wise, what kind of room do most people have for like a layout? Are most people here operating on like a 4x8 sheet of plywood, or more of something going around the basement? Okay, so in terms of curves then, basically the bigger the better. So I'm going to pass around this thing here. In real life, curves are measured by degree. So let me make a quick drawing right quick to make this make sense. So let's say that's our arc there. That's our point of curvature. That's our point of tangency. Let's call that the center of this. That's our radius. So the way that you may hear people talk about, oh, that's a 30-degree curve, that's a 28-degree curve, that is if you take a chord. I'm going to go back to basic geometry here. It's a 100-foot chord. The tangent coming off of here, that chord, that angle of deflection there, that delta value there, that is going to be your degree of curvature. So the higher that number is, the sharper the curve is. Does that make sense? So, and what those translate to in real life, for reference, these things here, this is from Railway Engineering's website. I think I've got enough where almost everybody can have one. I can print off some more if anybody wants them. But you can see that from that, so does an HO, like an HO scale, does an 18-inch curve sound like reasonable? Seems kind of sharp.
Tight.
Yeah, because that translates to a 45-degree curve in real life. In a 22-degree, for most things, 30-degree curve is kind of as sharp as a lot of stuff was designed to go, like particularly steam locomotives and such. So you're going to want to stick things more in the 25-degree and up range, or sorry, 25-degree and down range for your degree of curvature, which that translates into about a 30-inch curve. So this is one of the areas where in modeling we have to make kind of an exception for reality, in the sense of, despite the fact that a 6-foot curve would look absolutely beautiful with a big shiny passenger train going around it, nobody has a space for that. So most equipment that you have, you can buy off the shelf, is designed for like a 22-inch radius. For shorter cars, they'll do 18s. Shorter locomotives, they'll do 18s. Bigger stuff, 22 is kind of the minimum. 24 is ideal. If If you can do 30 inches, that's better. If you can do, as with many things in life, bigger is better. Oh yeah, I'll also pass around the paints. Before I forget, I just get this from the hardware store. This is what I use to paint my track. This is something we sell here. This is from Scale Coat. This is their flat rail brown. What's nice about this is that you can buy the exact same paint in a jar. So if you need to do touch-ups or whatever, you can just take a little jar of paint, your paintbrush, go back in and touch things up later. So, exact color match on that one. So, getting back into curves, everything's going to be a compromise. It's just kind of, it's unfortunate, but it's kind of one of the things with the hobby. I like big, sweeping, beautiful curves, but not everybody has the room for that. So now let's talk about roadbed. So, does anybody here, like when I say the word roadbed, kind of know what I'm talking about?
Yes.
So, going back to this handy-dandy guy here, the roadbed I used on this is just regular Midwest HO scale cork. It comes in a sheet, sorry, in a strip, like this here. This costs about $1.50 for 3 feet. You do get a discount if you buy it by the box, though I think it's 10% off. Anyway, cork comes like this, square, but it's got that 45-degree cut down the center. Tear it in half, lay it where the bevels are facing outward of each other, and this will not only give you, it's about a 1/4 inch of rise from your surface, but this will also give you a nice slope when you start laying ballast. It gives you just a little bit of extra definition and it helps things look nicer. As well, it helps deaden the noise, so pass this around. And then Woodland Scenics has this product here. I know it's popular overseas, so it's their foam roadbed. It's the same width, it's the same thickness, but it comes in one piece, and it's made out of a foam. It's a little bit easier to cut. It's something that I know is more common overseas. I've always used cork. They cost about the same. It just kind of comes down to a matter of personal preference. So the one advantage that the Woodland Scenics foam does have is that it is much better at noise deadening. So there's that. And for cutting that, I just use a box cutter. Just plain Jane old box cutter. Everybody's got one or two, or the same, like the super cheap box cutters you can buy in like the checkout line at Home Depot or Harbor Freight, where you can break off the blade and just work your way down. Those work great too. If you don't mind, I won't be passing around this one. So for laying down your oh yeah, before I forget, so it's kind of a note on narrow gauge here. So this is some narrow gauge flex track. Does everybody know what narrow gauge is? So this is.
Well, we got everything.
This one's from Pico. This one's from Micro Engineering. A lot of people like a model narrow gauge. My old layout was narrow gauge. I still have way too much of that stuff lying around that I will undoubtedly keep until I have the space for the Mega Dream Basement layout. So, just another example on the Micro Engineering. The detail level is a lot finer. The detail on the ties is better compared to the Pico. In my opinion, Pico is more flexible. Pico also makes their own turnouts, which we'll talk about later, and Micro Engineering also makes their own turnouts, which we'll talk about later. So, in terms of roadbed, here, I'll pass this one around.
Is there a cost difference between
I think one's like 50 cents more expensive than the other. So
50 cents a stick?
Yeah, something like that. And that Micro Engineering is made in Fenton, Missouri. This is made somewhere in England. So either way, including the turnouts, which I'll talk about later, the Micro Engineering and the Pico turnouts, they're all also made in either England or America.
So which are more expensive?
The Pico turnouts are definitely more expensive. Their flex track is pretty comparable. I'll talk more about those later.
Okay.
Cool. So for something else you can do for roadbed, something I encourage people to do is think outside the scale. So this is half a strip of O-scale cork. So you may be asking, why O-scale cork? Well, if you compare the HON3 track to the HO standard gauge that's going around, you'll notice that it's a lot wide. The HO standard gauge is way too wide. But if you notice, the O-scale track, the O-scale cork here, it's a pretty good thickness. The only thing it's missing is the bevel on one side, but you can either easily cut that yourself or just ignore it and fill that in with ballast. But This is just another option. I highly encourage people to think outside the scale, particularly for stuff like cork or ballast and stuff. Even though it says, you know, oh, this is for N scale, this is for HO scale, it may make more sense for what you're doing. A lot of people will also use N scale cork on the HO3. That's what we've done on our display layout over there that we're going to be building over the next few months. So pass this around. Just another example for those narrow-minded people interested in 3-foot gauge. So for laying out your track, what I did on this really wasn't following any particular plan, because this was just a little demonstrator thing. But when you're designing your layout, Kevin talked about this a lot in his clinic, which should be posted on YouTube and our website. He did one on track planning. I take the view that everything in track is just straight lines and circular curves. So what I talked about there, where it's just straight line going into a curve of a certain radius, it's amazing how so many things, particularly like in engineering, come back to basic geometry. Like if somebody asked me, what are the 2 most important math classes you took for college, it would be my high school Algebra 2 and geometry classes, because that is where I learned a surprising amount of stuff that still serves me very well. So on this here, I just drew this out. What's nice about the HO scale cork is that since it comes in 2 halves, you can break each half up. You draw out your line with a pencil or a pen or a Sharpie or whatever you have on you. You lay one strip of cork, and I'll talk about glues in a second, and be sure to stagger your joints, if that makes sense. So what I typically do is I'll lay my first strip of cork down, and then I'll take the other half of it, cut it in half, and then just place that somewhere in the middle so my joints are all staggered, and then I go from there. So for gluing down the track, there's kind of a few different options. Some people use liquid nails. Personally, I use good old Elmer's that everybody's been using since kindergarten. You know, it's funny, when you're a little kid, this stuff can't hold anything together. It like totally disintegrates, it doesn't work at all, and now it's like, this stuff's awesome. I go through this by the gallon. You can also use the Woodland Scenic Glue. It has these around as well. We don't sell the Elmer's here, but totally gloss over the remnant of price tag on this bottle here. You can see there, just plain old Elmer's glue. The Woodland Scenic glue, it's similar, it's got a bit more give to it. So like I said, I know some people who swear by that, some people who swear by the other stuff. That's one of the great things about model railroading, is that there are a million different ways to do something, and they're all right to a certain degree. And it's just a matter of not necessarily finding the thing that's the most right, but finding something that works for you. Also, some people use Titebond, just plain old wood glue, once again from the hardware store. If you kind of start thinking outside of the box, there's an amazing amount of hobby supplies you can just find in a hardware store. We'll pass this around again. Some people will also use liquid nails. So, you know, liquid nails like you just use for working in your house, putting on trim and stuff. That's what they use for that.
Use the same thing for the road bed at the end of the track?
Yep. So lay it down on there. Sometimes I will rough up before I start drawing things out. I'll rough up where I want the track to go with the sanding block, and then draw it out. Then put a bead of glue down each side, spread it out with my finger, or an extra piece of cork. Lay that down, and then for securing that, you can either use, to keep so it'll hold its shape, you can either take just little nails like this. Also, pill bottles are a great modeling tool. Everybody has some, or knows somebody that has a whole drawer full of them. And by the way, thank you very much for putting those over there. And just great, convenient little way to store stuff. Or what my boss likes to do is he has got a Feta Crumbles container full of push pins. So he will do the exact same thing, lay it out, secure down the cork with push pins, let it dry. The way I do it, I use the nails, and then I'll put books on top to apply a nice even pressure to make sure everything dries pretty flat. Then after the cork is dried, I'll let that dry for like a day, unless it's just straight, then I'll just give it a few hours. But particularly if it's on a curve, let it dry longer, let the glue do its thing more, and then come back with, once again, sanding block like this one, and go around and just rough up the top of the track, glue will get up between the joints and that'll stick up, so sand that down and then spread out another layer. Pass this around as well.
Question I'll interrupt you. So, what if you move a lot?
I will get to that.
Okay.
Another option. So let me finish my thought on this, and then, because I had to design my old layout to move, even though we ended up moving into the dumpster instead of with me into my new place, it was still able to move.
Okay.
Can I ask a related question,
Of
to see if
course.
you're going to answer it later? What if you're not ready to permanently put that cork on, if you're still experimenting with track?
So,
I don't want to permanently put it down, because I think I might move it, I think I might change it, I think I might change the radius, I don't know what I want yet.
fair enough. So, I will address your point first, and then your point, don't let me forget. And just for securing it on the track, I will bend the track into shape first, particularly if I painted it, bend it how I want it to be. You can use sweeps like this. So, and these are really helpful. So this is a 30-inch radius sweep here. You put this in between the track, and you just keep bending it until this is able to move freely in there. And if I want my paint to look pretty, I'll go take the piece of track off, take it out to the garage, give it another quick coat of spray paint again, and then let it dry. Or if it's someplace I don't care, or I haven't painted my track, I will just bend it until it works, put some glue, lift the track up right quick, put down a bead of glue, spread it out with my finger, put the track back, you keep it fixed in place with pins or push pins, and put books on top, let it dry, and then come back the next day. So pass these around. This is for a 30-inch, and this is for a straight. So these are made by Ribbon Rail. This is just a 10-inch straight. That's a 30-inch sweep, 30-inch radius sweep there. So they make it all the way from like 15 inches to 48 inches in 1-inch increments. So if you want to have a 47-inch curve, they got you. If you want to have a, if you need a 2-foot straight aligner, particularly if you're doing a yard and you want to make sure that all your tracks are nice and straight and nice and parallel, they make that too. So here's that. So talking about what if I want to change things around. So let's say that I decided, okay, I've got my cork here. I want to, instead of having this go like this, I want to have this go this way. I want to have it go the other way. So what I can do is I can take this little saber saw here. I'll bend this like this. So it's got a bit of an angle so I can get it underneath there. And then I can just come back underneath here. Oh, there's a pin. But sneak back underneath here and cut in between the foam and the cork. It'll come off pretty easily. I don't recommend trying to reuse the cork just because cork is so cheap. Just easier to kind of throw it away, and typically it'll come off in chunks. The foam underneath really won't be damaged. I actually had to do this because I decided to add in a passing siding on my layout when I was redoing some things on it, and I ended up having to take out some of the existing cork to do that, and it came up pretty easily, and I was just able to relay directly on top of there. Same thing with the track. Come back underneath here, and it'll all come up pretty easily.
And are you using white glue?
Yep. And also caveat, that's just using plain Elmer's white glue. I use that stuff because it's easy to get, it's cheap, doesn't give me a headache. I'm really sensitive to chemicals. I know like a friend of mine, he uses contact cement. So he'll put contact cement on the bottom of the track. He'll put contact cement on the cork, lay it down, press it in, boom, you're good to go on to the next section. Only problem with that is, for me personally, that gives me a headache. So, also, these are really good for cutting the cork. So just straighten this out again. You may notice here, my main track is going this way, but then I've got this track coming off of here. For these, I just put the cork up. I had my line drawn. I put the cork up next to it, and I kind of eyeballed it, and then just cut it at an angle with the box cutter. You can also do the same thing with this. With this little saw, to give you a bit of a cleaner cut and a straight edge, and yeah, so you can get whatever cut you need there. Pass this guy around. This is from X-Acto. This is probably the second one I've ever had. I highly recommend having one of these because they are useful for so many things. beyond just track work. That's just an X-Acto saw. Or there's a company, Zabor, Z-A-B-O-R, I think, that also makes them.
You get replacement blades for those?
Yep. I think that's like the third blade that I've had on that one. So,
How many teeth per inch is this?
I think that's like a 30-inch. That's one of the finer ones.
Yeah.
They do make them in like a coarse, medium, fine, and super fine ones. So, next we're going to talk about cutting the rail, joining the rail, and cleaning the rail. Yeah, then in between, before we talk about turnouts, we'll talk about, oh no, I'm moving, what do I want to do to keep things super light and easy to move. So for cutting the rail, here's a couple tools that I highly recommend having. These are both from Xuron. These are just a pair of tiny needle nose pliers, particularly if you're trying to get the rail joiners on, which I'll talk about in a sec. These are super helpful. I've got a curved nose one, and I've got a straight nose one. I use both of them all the time. I've got, on the underside of my layout is my computer desk. My layout's at about my eye level height. I've got some magnetic toolbars I think I just bought from either Home Depot or Harbor Freight. I highly recommend those. We also carry them here. But very convenient ways to just store your tools when I'm not using this. I'll reach under the layout, smack it up against the magnetic toolboard, let it go, and walk away. They're just little spring-loaded pliers. Super tiny pliers like this are very helpful. Another thing to pass around, and these are rail cutters from Xuron. The ones that Micro Engineering sells, they're just Xuron ones in their own packaging. This is probably like the third pair of these that I've had in about 12 years. They're really good. They're good at cutting rail. Don't use these to cut like piano wire or hardened steel. You will damage these. But elsewise, for cutting things like brass, these are pretty good. For cutting rail, these are awesome. I recommend if you're gonna be using this for more than just cutting rail, where you might accidentally cut something that isn't supposed to be cut by this, just having two pairs, keep one pair that's just for rail, and then one pair that's for cutting everything else. So for me, whichever is the newer pair, that I typically have two of these lying around, mostly because I'll have one and then I lose it for 2 weeks and then I go, oh crap, might as well just buy another pair. Or I'll use these and then accidentally cut something that it's not supposed to, which will damage the blade. I don't want to use it for cutting rail anymore. So always good to have a couple of these lying around. So for drawing out your track, tools that I recommend having, straight edge. This is just a two foot ruler here. This is usually used by our inventory manager to beat us into submission. So it kind of gives you the none vibe here. Tape measure, something and for drawing out your curves, you can either have, at home, I have a pencil on a string. So string's tied to a nail at one end. I wrap the string around the pencil until it's at the desired radius, stick the nail where I need to for the center of my curvature, and then just draw it out. Kind of not really rocket science there. Some people will also take a ruler, drill, so like at the 1 inch mark, they'll have a hole drilled for their pencil, and then they'll have holes drilled at whatever radiuses they want, and then they can just draw it out that way. So multiple ways to do the same thing. Cool, so we talked about that. Sorry, that's kind of one of the annoying, well, I shouldn't say the annoying thing, but just one of the things about this is that we're trying to go over a lot of stuff in just 1 hour, so I'm trying to make sure I'm on the right pack. Like tracks, so joiners, they kind of come in two overarching categories: non-insulating, so regular metal joiners, and insulated joiners. So you may ask, why do you want insulated joiners? You need those for some kinds of turnouts. It also allows you to have some tracks where they're powered by something separately. And I'll touch on that in a second. These are just Code 100 insulated, or Code 100 regular. These are little stamped nickel silver joiners from Bachmann. Atlas makes them, Pico makes them, Micro Engineering makes them. Pico ones, these are for their Code 70 track here. What's really nice about the Micro Engineering ones is that they're very small, they're very discreet. However, they're somewhat more difficult to get on. So on these, you may need to spread them out a little bit. I recommend just having a little flat tip screwdriver, like this one here. This is from Weha, which they're a German company. They make awesome screwdrivers. Another good thing to have in your tool chest, by the way, just use that to open up the flaps on the rail joiner to help get it in there. So And these are the code 70 joiners. These are the code 100. These are those compensating joiners, the transition joiners that I talked about. And then these are just regular insulated joiners. These are from Atlas, so this is their N-scale code 80. I use the, we don't have any in stock right now, but I use the Atlas N-scale code 80 rail joiners for both code 70 and code 83. For HO standard gauge, because they're a pretty small joiner. They're pretty discreet looking, but they're a touch easier to get on than the microengineering ones. And that just comes down to a matter of personal preference for me. The microengineering ones are harder to get on, but they look a lot better and they perform really well. But they just don't, for me, it's not worth it the number of times I've stabbed myself in the thumb trying to do that. Atlas makes this little tool here. Yeah, this one here. So prong here is for getting the joiner on. They do, one of these fits there. This one's for your it says on here, HO and an O. It just allows you to grab on to the joiner and stick it onto the rail without necessarily harpooning your thumb. This is like $5. I don't use it that often, but when I do, it definitely makes life easier. So another thing too, when you're joining your track together, particularly around the joints, maybe where you had to remove some ties, you may have an issue with gauge. So these are track gauges here. This is an HO scale gauge. This is an HON3 gauge. These are just also really useful things to have. You won't need this where it's just flex really, but where these come in most candy that I've found is where it's just where your tracks are meeting each other, you remove some ties, you don't have the ties holding the gauge here, so sometimes they can get a little loose or a little tight. So on the bottom here where it says track, that's your track gauge. This one here, this is for points. This should tell you how much gap you should have on either side of your points. Flangeways, no-go, wheels, these are just really useful things to have. Also the overall thing here, this is your clearance gauge. So something of this profile, everything you have should be able to fit within this profile. Say you've got a tunnel, you want to keep it to NMRA standards, you need to make sure that this can fit through that opening. Does that make sense? Cool, so this is for HO standard gauge. This is for HON3. I do both, so that's why I've got both gauges. In terms of keeping your track clean, so you can use, this is a Bright Boy for microengineering. It's an abrasive rubber block. You can use a fine grit sandpaper. You can use a fine grit sanding block. You can keep the track clean chemically, like using like a rag and Goo Gone. Wipe the Goo Gone on, then wipe it off with be sure to wipe it off with a dry rag. Or you can use Rail Zip or the various other track cleaning fluids that are out there. Woodland Scenics also makes a very convenient whole track cleaning kit that has a little arm with a pad on it that you can use to get into some extra tight spaces, which is very convenient. So, before we go on to turnouts and stuff, what do you want to do if you've got to move a layout? So, there's a lot of different ways you can do it, but I think a lot of it comes back to how much space you're working with. So you can either, how much space are you working with? Is it like you've got a ping pong table, or just something that needs to live in a closet, or?
I guess the footprint that we're going to be doing over Christmas is the same as the upper house, so about 1,600 square feet.
Okay. Oh wow. So something, a pretty big space.
My dad's been collecting since for. Gotcha. So you're looking for something. It's going to be semi-permanent, but be able to be taken apart. Correct. So for something like that, I would recommend a freestanding modular layout. So a lot of people will do it just using a 2x4 footprint. My old layout. Let me go back to the handy dandy board here. Big board. So does everybody know what I mean when I say modular layout? It's like you go to train shows. It's a layout that can just be broken down into smaller sections and show up in the back of a truck or trailer. So what I had on my old layout, it was composed of 2x4 modules. So I had one like that, another one like that,
And then I had another corner piece here. And I had a bridge going across here. What's nice about this is that each of the track sections here, my overall layout design was like that. Each of these sections were bolted together. I made sure that the scenery with these was not totally bonded, so when the time came for me to move out of the apartment I was living in, cut the track between the two, cut the wires, and then go in there with basically a chisel, or unbolt the set. I had these sections either bolted or screwed together, and then just undo the bolts or screws, get in there with a little pry bar, jimmy it until they just kind of popped apart. So that's something I would recommend as well, thinking about it if it's going to be going upstairs, or if there are any tight corners, really taking into account, okay, what kind of corners do I need to get this thing around? How can I make this easier on myself to manhandle this thing up there, because you're going to have to manhandle it out eventually. So if you're looking, and as well, if you're looking for something that is maybe a bit more flexible, you know, with how you can arrange things, say you move in, the layout comes out of there, it goes into a different place. That just comes down to a lot of like forethought, I would say, with how you plan your tracks. So when I designed this, I had the crazy idea in my head that I could eventually move things around. So, you know, this track here, my main line, it was 6 inches in from the edge, 6 inches in from the edge, 6 inches in from the edge. And then I had another spur going off this way that was also, you guessed it, 6 inches in from the edge. So theoretically, I could take this chunk here, swing it around, and add it onto there. Like I said, theoretically, never actually did that, because when it came time to take this thing apart, I was down to like 72 hours to get the apartment clean. That was the model train layout was the last thing to come down. Funny how that works out. So with respect to that, you can kind of go lightweight with it. Mine was 1x4s, just framed up with then like 1/4 inch sheets of 1/4 inch 2x4 sheets of plywood on there. You can make it even lighter. I've got a modular for a club I'm a part of that it's 2 3x5 sections. It's for O scale, so it's a little bit bigger, but it's 1/2 inch cabinet plywood ripped down into like a 3-inch strip for my subframing, and then a 3/8 inch sheet of plywood on top of that, and then a 1-inch sheet of foam like I did here on this. And then I think that only, gosh, each of those modules I think only weighs about 20 pounds. Like the module itself before I started adding track and scenery. So particularly if it's something that's going to be kind of more long term, it depends on, you know, what you're aiming for. If it's something that's going to be used pretty regularly, you have to kind of approach it with that in mind of how do I make this easier on myself. If it's something that you know will need to move eventually, you can kind of make things a bit more permanent, and if you're okay with it, just know that, okay, some of these things I'm going to have to take out with a Sawzall. So it just depends on how permanent and how modular you want the layout to be, because realistically, all the layouts we're going to build are going to be temporary in the grand scheme of things. I can't imagine my future kids keeping a house around with a giant model train layout in it just for fun. So, does that answer your question? So, quick notes on wiring. So, color coding is your friend. Don't worry, I will get to turnouts since the last part about this. So, I highly recommend color coding. It will make your life so much easier. I remember I built my first layout when I was 8. It was on a full grain sheet of plywood. I only used black wire. And that was always fun because I was the only person who could figure things out. Later on I figured out how to tag things with masking tape. But keeping your wires neat, keeping your wires color-coded, keeping things labeled makes your life much easier in the end. So this is how I have this set up. I've got my main track power bus, so what's actually supplying power to the track is red and black, and my accessory bus here is yellow and green. You may ask, why red, black, and yellow and green? Because that's what the Radio Shack by my house I had growing up by my house had. So you kind of work with what you got. I've started using blue for frogs, and I'll talk about frogs in a second. Now we're talking about a track component, not an amphibian. So color coding, it will definitely make your life easy. For easier, like wire maintenance, I will periodically staple things. So I've just got a
regular staple gun you can buy at Home Depot or whatever, and I'll staple the track periodically, like to the underside of the layout or to the side of the framing, whichever makes the most sense. As well, when I have it going from like different sections of framing, I'll drill holes. If I had like an intermediate support here, I drill a hole through that, which that also counts as a support. Also, if you've got a lot of things going on in one place, zip ties and labeling is your friend. I highly recommend, if you're going to be doing something that's reasonably sized, just get a big can of zip ties from the hardware store that's got a lot of the small ones in there, and that'll make your life much easier. It's much easier to do it on the front end too than going back 2 years later and going, oh my god, I need to fix this. So make sure everybody can see this. These kind of make sense.
The green and white are sub bus?
Green and yellow are accessory. So if I wanted to have like lights and buildings and stuff, that's what I'd be powering off of this.
Would you have a separate power supply for that?
Yes. So on my layout at home, I have a DC transformer, and then I've got my 2 DCC systems. I just have my layout operating on one bus. I don't have it broken up into like power districts, because that doesn't really make sense, in my opinion, for the size of layout that I'm working with. If it was much bigger, like if I had more than one town, because for me, my layout, it's one town and then a loop going around the rest of the room. So
you said you had 2 DCC systems?
yes. So I can switch back and forth. I just have a double pull, double throw switch for MRC and NCE. I grew up using MRC. That's what I've had on my previous layouts, but NCE is much more common around here, and I got that partly so I could, be better at my job here, and it's a system that I also enjoy using, and what's the best way to learn how to use something than to actually use it. So I can switch my layout back and forth between being controlled on DC. My DC transformer also supplies my accessory power, and I can switch back and forth between DC, and then on the DCC side, between NCE and MRC as I choose. So for supplying power to the track, there's basically 2 different ways you can do it. You can either do what I did here, which is drill a hole and solder a wire to the rail. Those are typically just called drops or power or feeder wires or whatever. Or you can use these guys here. So these are from Atlas. They are just joiners with the with wires already attached to them. These make sense if you're starting out and you don't like to solder. Personally, I take the viewpoint of I put in a power drop every new piece of rail or every 3 feet, whichever comes first. I don't like relying on the joiners for electrical pickup, particularly if you plan on ballasting later on, because you'll start ballasting, glue will get in there. It'll just be a royal pain. You'll start losing electrical connectivity across the joint. I take the viewpoint that joiners are just for mechanical alignment, and your power drops to your main bus line. Those are what are actually supplying the power to the rail. Does that make sense? Some people will also solder their joints. I do that sometimes if I'm already there and it's convenient, and it's something. I'll do that sometimes on turnouts here. So like, say for this part here where I've got this frog here and this rail, well, it doesn't always make sense, depending on how lazy I'm feeling that day, to have a drop for this 2-inch stretch of rail, so I can just solder the joiners and kind of cheat that way. I'll pass around these terminal joiners. These are both from Atlas. One's their code 100 joiner, one's their code 83. So for doing the drop, and I can do a demonstration of this later, we're doing all right on time. When it comes to actually connecting the wire in, then to your main power bus, you've got 2 different options. The way I did this here, I just stripped the wire on my main power bus and tinned the wire that I was going to be soldering to it. So heated it up with a soldering iron, put some solder on it, and then wrapped it around there, heat it again with the soldering iron, call it a day, and go home. You can also use these little fellows right here. These are called suitcase connectors or quick splices. What this does is that you've got
One part of this here, so you'll see there are like 2 holes here, and I'll pass this around in a second. This one here goes all the way through. This is what you stick to your main bus wire. This one here, this is what you stick your feeder wire into. This will basically kind of clip on the wire. You stick your other wire in there, and then this little steel plate here has some nice holes in it. You come in with a pair of pliers, you squeeze that until it's flush with the top of this, and then that will cut through the insulation. You make physical contact with the rail, and then you come over with a little cap on it and close it like a little suitcase. Does that make sense? Cool. So another thing for soldering, you can use a few different types of irons. For most of my soldering work, I'll just use a pencil iron like this one. I'll be turning this up. So with people, I'm going to talk about ballast, I'm going to talk about turnouts, and then I'm going to talk about ballasting. I can do either a live demonstration of soldering a power feed, or I can do a live demonstration of ballasting, or I can do both if people want to stick around. But any particular preference on what people would like to see? Both?
I'll stick around.
I'm happy to stick around.
Okay, cool. Just don't want to take up too much of your time, because this is supposed to only take an hour, but trying to fit a lot into the space of an hour. So another good thing to have in your tool chest is a file. Once you join your rails together, the tops may be a little mismatched. Hit it with a file, that'll smooth it out as well. I recommend you file if you're going to solder in a power drop, hitting the area with a file just to clean off any surface corrosion or whatnot. You can then apply flux. So flux is stuff that'll chemically treat it'll basically chemically get rid of the surface oxidation that's on the surface of the material. This is some wonderful brown goo from Radio Shack. This is their rosin soldering flux. I've had the same tub since sometime early in high school, and the amount really hasn't gone down by that much. To apply this, I'll use the end of a screwdriver or a chunk of tie, or sometimes my finger if I really just want to get it done. Hit this with the soldering iron when it's on the surface. It'll like fizzle away, and then your surface is chemically clean. So pass that around here. These are from PBL. These are a couple fluxes that they make. What's nice about this one is it has this nice needle tip on there, which does make life easy if you're getting into tiny areas, but it's more expensive. This is their Stay Put self-tinning flux. This actually has some, I think, zinc floating around in it. So when you apply this, it'll not only clean the surface, but it'll tin it as well. So put on a little layer of metal on there that you can then solder, that's in for melt, you can more easily solder to. So we talked about wiring, we talked about that, we need to talk about turnouts. So,
before you get into turnouts, I just have a quick question on this. It says 2218.
yes, so that's referring to the wire gauge that's made for. I use on this stuff here, this is 22 gauge stranded wire. I really don't have any opinion of stranded versus solid core wire.
Well, my question is this, I'll just make it real quick. Your bus wire is going to be a much larger gauge.
It can
than
be.
your feeder wires.
So if I was building a basement size layout, I would definitely use a larger size of wire for my main power bus, but since my layout's still just small room size, I use, just out of sheer laziness, I use 22 gauge all around. So that means instead of having to deal with, 8 colors of wire, 8 spools of wire, a large and a small of each color, then I just have 4 spools of wire, and it's easier for me to keep track of. That's my own personal preference.
Do they make those suitcase connectors with a wider range on them? For like 14 to 22?
Yes, they do. They do.
All right.
These are for 18 to 14 gauge. The blue one's here. So pass that one around too. So
Yeah,
we got to take a water break here.
We are.
You'd think with as much experience as I have opening my mouth and not shutting up, I'd be better at it. So, going back to our original thing with these pre-bedded turnouts, so this is from Cato. What I like about the Cato Track 2, and if it's something that's kind of temporary, if you just have a layout in a box, I have a loop of Cato track that I can set up on my living room floor. and run trains, because I haven't completed the loop all the way around my room yet. So I still can't run trains sometimes, which kind of frustrates me. So sometimes I'll just set up a loop on the floor. Kato track, this fits in with their system. What's nice about this too is that this switch can be remotely controlled. See this plug here? This goes back into the back of a controller that fits with the Kato system, and it fits in perfectly with their power pack system and allows everything to be very easily controlled. I can talk about that more afterwards if you'd like. So, an example of that one there. So, next, coming back to this stuff here, we have the Atlas turnouts. So, Atlas, been around a bajillion years. They make, what's nice that they do is they make turnouts that are in specific curvatures. So this here, this is their 22-inch radius turnouts. That means that this curve coming off of here is a 22-inch radius, which if you're trying to say do a loop within a loop, that's really convenient. It's not quite prototypically accurate, but if it's a sacrifice, if it's something you want to do, it's not a big sacrifice to make. This comes with their little, they have a little solenoid in here that you can then use to run these wires to this controller here, and then this controller you run power wires to the accessory power coming off of your transformer, and then you can use this to remotely throw this switch. Say you've got a layout, you've got a turnout on the far side of your layout, and you don't want to have to go over there every single time to throw it. There are a few different options you can use for remote controlling it. So does this make sense? So here's another one. This is what I put on the underside of this. This is from Blue Point. This is it's a manual control. So it's got a built-in DVTT switch. I can show you more clearly up here after we're done with that. Another option for under layout controls. Has everybody here heard of like tortoise motors? Cool. Another option, slow speed stall motor. Rapido makes their own version. Pico makes their own switch control as well. It fits in with their track. It actually is made to kind of clamp onto the underside of it. So for switch nomenclature, let me draw another terrible picture here. Pretend that's a parallel. Sure. So on this, we've got the points, the frogs, and the guardrails. So it'll make more sense on the turnout. I'm going to pass around here. This is a number 6 turnout for microengineering. So what that number refers to is the kind of the steepness of the curve, or the sharpness of the curve. The larger the number, the more shallow of a curve it is coming out. So what that actually refers to is that say this turnout here is a number 6. You go out from your frog here, which is where the rails cross each other. It's typically a casting. And you go out 1, 2, 3, 4, 5, 6 feet. That means that this distance here will be 1 foot. Also, not to scale. So let's say you've got a number 4 turnout. That's going to be a much sharper turnout than this, because this is going to be wanting to get away from this much quicker. The microengineering ones, they are definitely the more detailed turnouts on the market. There's less availability though. Right now in Code 83 they're only making number 6s and number 5s. I think they've got some plans for curved turnouts in the future, and number 8s, and adding some other larger turnouts and different turnouts in there. The microengineering ones, the frogs are isolated, so you may notice on this, the frog is where things can get interesting from a DCC perspective. The Atlas ones, the frog is plastic, so they just ignored that. Basically, this is where you have your say this is your left rail here, this is your, that's your left rail, that's your right rail. You got your right rail and your left rail, suddenly they cross, oh no, they're confused electrically. So the way on the microengineering ones, the frog is totally isolated, and it's just separate casting. So if you don't have this wired in, it'll just be, you'll have a little bit of dead zone. This will still be right rail, this will still be left rail going this way. If you want to have the frog powered, like I have it wired for here, I have a blue wire coming off of the frog that's soldered to the frog, that when I have the turnout thrown,
if the turnout's thrown this way, say the other way, so train's going straight, then this thinks it's a right rail. This is supplying right rail power. If this is going diverging, this thinks it's a left rail. Does that make sense?
So the,
Yes, but how do you do it? More detail, please.
More detail, cool. So,
where
I'm
do
sorry,
you-
I didn't
where
mean
do
to
you-
hey, it's all right.
Well, it was a very similar question
Cool.
to what I had. So where in the frog are you attaching the wire?
Where'd I do it on this one? Did it on the side of this one. You can. Some people will do it on the underside. I'll bring this around to you. Delivered. It's just soldered to the side there.
And down through?
Yep. Down
But it's
through a hole.
just one side of the frog?
One side, but it's one casting. So all I have to do is make one point of electrical contact.
Okay.
Cool. And then for actually controlling which way or which is supplies power to which, what's nice about the blue points is they have a built-in DPDT switch. It doesn't pull double throw. So I can solder this to the center post here, solder whichever goes to the left rail to this, whichever goes to the right rail to this, and then that will, when it's thrown this way, it'll be, the frog will be correct. And if it's thrown this way, the frog will be the correct polarity
So now I'm
where the track is
understanding.
aligned.
We need one of these if we're going to power the frog.
Or if you're using a tortoise, they'll do that. If you're using a repeat, the tortoise control motors, they'll do the same thing. Repeatos will do that as well. Some people will just say to heck with it. You're only losing like 3/4 of an inch of electrical pickup. Having it powered will make your operation smoother, but it's not the end of the world if you don't have it powered. You may just sometimes have something that, for whatever reason, has to die on that little stretch, and it needs a nudge, or it'll stutter and then keep going. So if you want to have smoother operation, definitely recommend powering the frogs, but it's not the end of the world if you don't.
Cool.
Now,
Their Pico makes an electrofrog.
oh, aren't you? Because that's the next thing I was going to talk about. It's cool. So I've got the electro frogs here and the insul frogs here. So same turnout. This is a left-hand number 5 turnout, so you'll notice it's sharper than the microengineering one. There you go, sir. But I'm passing around. So I'll start with the electro frog first. The electro frog, turnout's thrown this way. The frog is powered to be a left rail. So you have both these rails here thinking they're a left rail. So you'll need to insulate. What I recommend doing is throwing an insulator on, basically on these 2 points coming off of here, because if you have this, wired for continuous pickup all the way through, so you've got your rail coming in on this side, well, your rail here is going to think it's a right rail, which is fine when the turnout is thrown the other way and it's aligned for this. But when it's thrown this way, suddenly this whole assembly here thinks it's a left rail. Yes, left rail. So you'll need to have that insulated to avoid short. Does that make sense? Cool. And if you want, give me your email and I can send you a very good article that describes it with much better pictures than I can draw. So that's a way to get the power, so you can power the frog without having to have another controller underneath there. But you just need to remember to have things appropriately insulated.
So then, is the loss of power in the frogs, is that something unique to the turnouts?
Yes.
Okay.
So
Pass that around.
is Pico the only one that makes a non-insulated turnout or a non-insulated frog?
Yeah. Well, actually, no. The Shinoharas, and by extension, then the Walthers Code 83 ones, they operate the same way. So you will need to have the. Actually, no. The Walthers Code 83 ones, those are DCC friendly, so they already have the frog isolated. So you can go in and power the frog if you want. The regular Shinoharas, which there's still a lot of those floating out there, whichever way the track's thrown, that's how it's going to power the frog.
Okay.
Does that make sense?
So there's no need really to power the frog if you have anybody other than the Pico.
Yeah, if you're using the electro frogs, the frog is already powered. You just need to have things appropriately insulated. If you are using, say, the microengineering, then if you want to have continuous pickup, then you are going to need to power the frog.
Okay.
Does that make sense?
Yeah. But you still have that piece of plastic in there
Yeah.
where there's no power.
Yeah,
at all.
where there's no power, that's for like the Atlas turnouts. And then,
Can I get you to email me something you're going to send?
cool, yeah, I will, here, we'll
You
go.
send it to everybody.
Yeah, go over that at the end. I will send that to everybody. So, this is the Insel frog. So it just glosses over that issue of, oh no, which way is the frog powered by? You just have that same little 3/4 of an inch, 5/8 of plastic there that acts as insulation, and you don't have the electrical contact there, but your wiring is a lot more simple. Does that make sense? Cool. So then, quick overview of HON3 turnouts. This is the microengineering one. It's exactly like their big one, except it's HON3. Same thing, frog's insulated. You can power it if you want, but that's your discretion. They do have a nice inbuilt snap in them. Like the Picos, it's not as aggressive as a snap as the Pico, but it still definitely will get you through without having a turnout control. And then here's the Pico HON3 one. What they've done here is that it's neither Insel frog nor Electro frog, in the sense that the frog is isolated, but it's pre-wired. So on the Insel frogs, you can't really wire the frog. This one here, you can. So you can already, it already has a feeder wire. The frog drop in there. You drill a hole for that through your road bed and through to your wiring. Wire that into whatever's controlling the turnout, and you're good to go.
But if you don't have something, if you're just controlling them manually,
If you're just controlling them manually,
you
then
don't hook anything up.
you can add in a DBTT switch or an SBDT switch, so either a single pole or a double throw switch, single pole, double throw, or double pole, double throw switch in there. Both of those will work, and I can show you where those are in the back to then just, so you'll have two controls. So you've got your caboose ground throw to throw the track, and then you've got the other switch on the side of your layout or something that then controls the polarity of the frog.
Okay.
Cool. So, let me get the solder iron plugged in. And this will take a few minutes to heat up, but, so what we're going to do is we are just going to wire in a drop and then we connect it in with the suitcase connector. So, and by the way, the class is officially over now, so for those of you that don't want to stay for this, feel free to, my feelings won't be hurt if you want to go do something else. So, first I'm going to drill the hole for my drop. I'm going to do one on this here, so also something I did is that I wrote in big letters, red, black. All the tracks, all the rails that are on this side are red wired. All the ones that are on this side are black wired. So just an extra nice convenient thing that I do recommend that you do when you start wiring your layout is just write that on there, because it's really annoying when you start, doing your power drops, and then when you're on the underside of your layout, connecting your drops into your main bus, well, suddenly you've got a red flipped around in there somewhere. It's going to cause a short. So you're either going to have to take that out, put it in the appropriate colored wire, or just have a red drop going into a black bus, which will drive you crazy if you're somebody like me. So this is just regular drill, 1/8 of an inch drill bit. The annoying thing about using the 1-inch foam is that it does kind of take more travel to get through it, if that makes sense. So I'm going to pick a spot here where I want to have my drop. And be careful too, particularly like when you're waiting for it to go through and put too much pressure on it and it just kind of slams down, then the end of your drill can hit the track and do some damage there. So just something to make life a little easier. I'm going to take a little length of, red wire. Only need about 4 inches. Then I'm going to strip the end off. Oops, got a little bit too aggressive there, so let me try again. Cool. You can also use your teeth. That's personally what I do a good job of the time if my wire strippers aren't close by, but your dentist will get mad at you, so. Let's see. Cool. That's getting hot enough now. So first what I'm going to do, let me get this in here, is good. I'm going to come in here. I'm going to tin the wire. This is just 6040 rosin core solder, also from the store formerly known as Radio Shack. Give you an idea of, you know, how long it takes to go through a spool of this. I think this is also something that I've had this spool for like 4 years. So first, just going to put a little bit of solder on the tip. And by the way, please feel free to stand up and take a closer look. Yeah, this is one of those things that unfortunately is definitely hard to do in a larger demo. Yep, so that's getting hot enough now. So I'm going to take wire, touch it to the end of the iron here, let the wire get hot, and slowly dab the solder on, because I want the wire, or the solder, to flow into the wire. Cool. And here, next thing I'm going to do, sorry, I forgot to grab my pliers. Another soldering thing here. Also, another thing you may notice, on the underside of your lap, if you're doing soldering, while it's kind of a dumb idea to hold your soldering iron in your teeth, it's an even dumber idea when you're doing that to look to the right. As the burn that is perpetually on my right arm, for whatever reason I do it like once a year, soldering overhead, I've got the soldering iron in my teeth, I look to the right and I burn myself in the exact same place. Don't ask me why, that's how that works. So, I'm going to bend the wire, just make a little L out of it, where it'll fit right nice and cozy up next to the end of the rail, up to the side of the rail rather. And I'm going to take, would you mind handing me that, the big tub of solder? Yep, that one. So, what I'm going to do here, I'm going to open this and hope that, yep. I'm going to take a little bit of, just a little bit of excess wire, dab that in there. Oops. Sorry, for all the people watching out in radio land. Take this, and I'm just going to put this right where that's going to go. Take my iron. Get that. It's going to kind of sizzle off there. That's going to take care of my surface oxidation. Also something even if you're right-handed, you'll end up having to learn how to solder with your left hand. So, I take this here wire, I'll stick it through here. Sometimes you need to give a little twist, help it get through. Or just hit it with a drill again.
I think so.
Why do you look at me? No, that should work. Swear I'm not crazy, it's just a really good impression. Oh, nope, there it goes. Stick that through there. Now, I'm going to bend the wire so that it's kind of pushing into the side of the rail there, since I can't really support it from the other side. I'm going to come back here with the soldering iron and act like I'm left-handed. I'm going to hit the rail with the iron. Really, most of what I'm trying to do is heat up the rail so that it melts the solder. It should be doing here. It'll take a second. I think this is only like a 10-watt iron. Touch it there. add a little bit of extra soldering, and then boom, I just made a drop. Take this here file the top of it smooth.
Does it matter what, like, I don't know, what grade or what is it called?
I mean, this is kind of, yeah, this is kind of a coarser one than I would like to use, but this is what I had lying around, so a lot of it comes back to what you might have lying around. So I've got my drop there. I can make sure that my drop is good, give it a tug on the bottom of the layout. If that's good, then we're good to go. Next thing I'm going to do, I'm going to secure it in with one of these here suitcase connectors. Also, don't do that. Be sure to always unplug your soldering iron when you're done with it and not burn yourself. I'm going to take handy dandy Leatherman here. I'm going to secure the outer part here. Just can't see it on the camera, so. Take my main part here. It'll kind of clip on the wire. I take my feeder wire. I put it into the other side. I come around here with my pliers. Press it through. Give it a good squeeze. Close the suitcase. And then, boom, we have just made a drop. Congratulations, you've just learned about 60% of wiring.
So you don't need to buy those $100 pliers?
I mean, you can, it'll make life easier, but I mean, in my opinion, tooling is everything.
Yeah.
So, it makes life easier, but it's also not the end of the world. So there's that, and for those that want to stick around for the ballasting demonstration, we'll talk about ballasting.
Do you need a Band-Aid?
Oh, I'm good.
Okay.
Also, you'll just kind of get used to burning yourself for the soldering iron. So, first thing I'm going to do here, I'm going to ballast this last little section of track here. I'm going to come back in with my cork. I'm going to clean off the bevel there, because one side of the bevel usually isn't too smooth. Blow that away. First what I'm going to do is I'm going to put down a base coat of El Cheapo acrylic paint to hide the pink, because you don't want to have that pink really coming through. It's not going to look good. So, yeah, it's good. This is, once again, very cheap stuff that I picked up at a hobby shop or a major hobby place that also has a nice lobby, if you get what I mean. I'm just going to put a little bit of this down, take a cheap foam brush, and I'm going to spread this around here. This will give me a little bit more coverage, help hide that pink. A little bit more down there. It doesn't have to be perfect. And especially by the time you start putting on scenery foam and stuff, you're not going to be able to see the pink. But every little bit of insurance you can put on there to keep it covered makes life easier down the road. Some people they'll mix like sand in with their paint. You can also, what I've done in the past too, is you just go to Home Depot or Lowe's or whatever your favorite hardware store is, and check out go to their paint section, and typically they'll have cans of paint there they mixed up, that people didn't want them, and just find something in a good earth tone. Also, you may notice kind of a hole in the foam here. That's when I had a bottle of super glue fall over. Super glue will work on foam, but you have to get super glue that's safe for foam. Elsewise, that happens, and that's what we call an oopsie-daisy. Would you mind handing me that bottle of Elmer's glue? Thank you very much. Cool, so we got our Elmer's glue here. I'm just going to put a little bead of that in the bottle. Put a little bead of that along here. Normally I'd wait for the paint to dry, but for the purposes of this here demonstration, we're not going to worry about that. And then, since we got my glue spread out there, I am going to just spread it out with my finger. No, I remember an elementary school teacher saying, nobody will pay you to play with glue with your fingers. Joke's on you, Mrs. Hester. So, for ballast, there are kind of, I see two different major options. Woodland Scenics. This stuff is made from crushed walnut shells. Color's very uniform, the size is very uniform. But I tend to use I've started using the stuff from Arizona Rock and Mineral. It's actual crushed rock. It looks a lot better in my opinion. Because I'm pretty sure it's a guy going out to like a Southern Pacific yard with a 5-gallon bucket, getting some stuff and then taking it home and crushing it. So I'll tear a little, typically I'll keep the stuff in the bag it came in, tear a little hole in the corner, and then I will just come back and spread it out. Don't do it all at once, kind of go back and forth in layers. You want the glue on the side there to help take care of the, that help hold things up for the bevel. I'm going to take a little brush here. You can use an acid brush, you can use a foam brush. I used to use a foam brush, but now I just kind of I'll just pick a brush and it's like, that's my new ballast brush. Come back through here. Try and get everything off the top. And as well, come back on the edge here. Pat things down. Make it look nice. Brush things out to the end. Oh, cool. So I kind of got that. How long it? And ballasting will be a huge mess. There is no way around it. For that, I can give nothing but a just comes with the territory. I've got kind of my ballast, how I want it. And then you may notice this little bottle here. So this was the end of a bottle of Elmer's glue that there was like ½ inch left in the bottom. I filled it up the rest of the way with water and added a drop of dish soap. What the dish soap does is it helps break up the surface tension and it helps the glue soak in. So since this has been sitting for a while, you can also just use like the straight matte medium over there. You can use this stuff right here. You can use this stuff straight out of the bottle. But this is what I tend to do just because shake this up. I like using the bottles with the tips, with the narrower tips on the end as opposed to the flat tips, just because it does make it very easy to come back and slowly drizzle this on. It's going to soak in. This might be a little bit of a heavy mixture, but we shall see.
Could you say your ratio of water to glue?
4 to 1-ish. So this is going to look like hell here for a little bit. If it seems like too much in one place, just come back with a paper towel and blot it up. Elsewise, let that dry, sometimes overnight. Or typically I let it dry overnight and come back the next day. Push it with my finger. If it doesn't feel like firm enough, just hit it again with more diluted glue.
How much soap did you put in there?
Just a drop.
Drop. Which one?
Like Dawn.
Dawn.
I think I've got Ajax at home, so.
Do you find that there's yellowing after time within this?
Not really. I mean, you'll get a little bit of yellowing on the top of the track, but that's just because it's the nickel that's in there, and that's part of the tarnishing. So if you come back in with a track cleaning block or some sandpaper, and just polish off, like really fine grit sandpaper, polish off the top of the rail, you're fine. Cool, so it's kind of that. Congratulations. Ballasting does get to be a pain around switches. That's where it really, kind of the rubber meets the road on that one. Just because you've got the moving parts there, you've got more stuff. Particularly, you need to make sure that ballast doesn't get in between the main rail and the guard rail, and that little gap in there that will cause stuff to derail. That's where just one of those things, after you do your ballasting, just come back through and just make sure everything still works. Come back through with like an X-Acto blade or a small fine tip screwdriver, and just if there's ballast in the way, just pick it off. Cool. Well, does that answer everybody's questions?
How do you do the ballast around all those soldered joints without causing causing lots of issues? Do you just kind of work around it, or?
I'll typically hit like if I really care, I'll hit the solder joints with like a paint pen, which is nice if you're using the scale coat stuff, since you can get the exact same color paint in a jar. Just come back with a brush, put that on the solder joint just to hide it, and then just ballast around it like you would anything else. Because it's soldered to the rail. It has a, its surfaces have been melted together. It's got a good bond there. So, and that's why I say also after you do your solder, just give the wire a little bit of a tug. Cool. Congratulations. That's our overtime. Once again, I went over by like 30 minutes. Thank you for paying attention. I hope I didn't bore you.
Thanks very much.
Yeah.